All right. Hey guys, this is Mrs. Lyons, and I just want to take a few minutes to go over this quiz so that you can make corrections on it and you can know what mistakes you made. Okay. So starting with the popsicle, what you need to remember here is that heat flows from the warmer object to the colder object. Okay. So the way that I always think about this is I know that, and we'll use degrees Fahrenheit since that's what we're familiar with. I know that if I take this popsicle out of the freezer and it's frozen, okay, it's going to be 32 degrees Fahrenheit at least at the highest. Okay, it's frozen, so minus 32. The air in the room, if you're in my house, the thermostat's set at about 68 degrees Fahrenheit. Okay, so the energy, the heat, is going to go from the room into the popsicle. So heat is going to be absorbed, causing the popsicle to melt. Okay, that makes this endothermic because heat's being absorbed. All right. Number two, it tells you, here's the key, almost immediately the bag became too hot to touch. Okay, so if it feels hot, that means that energy is flowing from the reaction, the Ziploc bag, to your fingers. So that makes that exothermic. All right. This next one, it's asking you to rewrite the equation and include the energy. So we're going to rewrite the equation. We're going to go NH3 plus HCl. And then on the other side, I have NH4Cl. I have to figure out, where do I put this energy? Since the energy is negative, that tells us that this is an exothermic reaction. That tells us that heat is being produced. Okay, so heat is a product. All right, so heat is going to go on the right side of the equation. Now here's a mistake. A lot of people made this mistake. They put in minus 176 kilojoules. Okay, when you're putting it into an equation, you put it in as positive because you're showing what the products were. And heat was a product of the reaction. So we're going to put in 176 kilojoules. Okay. And that is exothermic. The graph, all right, is exothermic because the reactants are at higher energy than the products. All right. Number 5. This one is just kind of the opposite of number 3. We see that the energy is on the reactant side, okay? So because it's on the reactant side, that tells us it's an endothermic reaction, right? And that means the energy is absorbed, so the energy is a reactant. So we're going to write plus 483.6 kilojoules. So all you have to do is just write the number. If that would have been an exothermic reaction, if the energy would have been on this side, that would have been a negative number. Okay? All right. Now we get into some of the thermostoic. All right. And remember, we said that we can convert between grams and moles and energy. Okay, grams to moles, we need to use the molar mass. Moles to energy, we need to use the balanced equation. Okay, so let's look at how that works. How much heat had to be absorbed? Okay, so right there, that word absorbed tells you that this is an endothermic reaction. Another clue is that your delta H is positive. That's also a sign that it's an endothermic reaction. Okay, in order to produce 13.7 grams of nitrogen. So we're going to start with 13.7 grams. Look in our equation, nitrogen is N2. Okay, so we're going to write 13.7 grams of N2. This is going to go over 1. Now, we're starting with grams. So we need to first convert to moles. Okay, so on the bottom, we're going to have grams of N2. On the top, we're going to have 1 mole of N2. Okay, and when we're looking for grams, remember, when we're looking for grams, we are always going to look at the periodic table. If you look at the periodic table, the molar mass of nitrogen is 14.01 grams. We have 2 of them, so that's going to be 28.02 grams. All right, and then our final step is to go from moles to energy. So on the bottom, we want moles of N2. And on the top, we want our units of energy, so kilojoules. And this is where you have to look at the balanced chemical equation. The moles of N2 is 3 because the coefficient for N2 in that reaction is 3. And then the energy is going to be 3352 kilojoules. Now, if I plug this into my calculator, I get 13.7 divided by 28.02 times 3352 divided by 3. I get 546.3. Why do I not think that's right? Oh no, that's right. 546.3. So 546.3 kilojoules. Okay, so that's our answer there. Okay, flipping over to the back side. We have another thermostoic question. All right, this one, however, is asking for moles, and it's giving us kilojoules. So I'm just going to write my little helper up here, grams to moles to energy, kilojoules. All right, so it's giving us kilojoules. We need to just do one step to get to moles. Okay, so 572.8 kilojoules. All right, so that tells us on the bottom we're going to have kilojoules. On the top, we're going to have moles. What is it we're looking for? Moles of sodium, so moles of Na. All right, I look at my balanced chemical equation for the coefficient is a 2, and then kilojoules. This is on the exothermic side of the graph. So something we need to think about, okay? This is going to be a negative number, so negative 411. The other thing we need to think about is in our question, it said that this energy is going to be produced. So that means that this is minus 572, okay? And I'll explain something in just a minute. So we've got minus 572.8 times 2 divided by negative 411. So I get 2.79 moles of sodium. Now, even if you forgot the bit about the negative signs, okay, I want you to think about this, okay? When you get an answer, this is moles, okay? Can we have a negative number of moles? The answer to that is no, okay? So if you think about what you're doing, okay, even if you forgot to put the negative sign here, you should go back and think, oh wait, this cannot be a negative number. This has to be a positive number because my units are moles, okay? So just kind of keep that in mind. And then since our kilojoules are on the product side, that means that this is exothermic. All right, our graph. Okay, it asks us to label products, reactants, activation energy, and the heat of reactants. Okay, so you could have put R for reactants and P for products, but when I give you an equation, you could also put H2 plus Br2. Those are the reactants, and over here, HBr are the products. So either one of those was acceptable. Okay, remember that, and I'm just going to kind of extend another line across here. Okay, remember that activation energy is the difference between the reactants and the very top of the graph. That is our activation energy. Okay, and then delta H is the difference from reactants to the products. Okay, so delta H, and since we're going up, that tells us that delta H is positive, which tells us this is an endothermic process. Okay, now what is the activation energy for the reactant? Okay, so the activation energy is the difference between 50 and 130, so 80 kilojoules. All right, what is the heat of reaction? Delta H. What's the change in enthalpy? Okay, so we're going from 50 to 100, so that's going to be 50 kilojoules. Okay, and then finally, the last question on this quiz was to calculate the delta H, to calculate the change in energy. And for this, you've got to look at our average bond enthalpy. Okay, so if I look here, I have got a nitrogen triple bonded to a nitrogen. So that's going to be 941. Okay, and I've just got one of those. And then I've got 1, 2, 3. So I'm going to write N triple bond N. I have 3 H triple bond H's. All right, let's see, where is that? So that's going to be 3 times 436. So let's just do that math real quick. 3 times 436 is 1308. So my total energy for my reactants is going to be 1308 plus 941. Whoops. 1308 plus 941. So 2249. Okay. That's what's on the reactant side. Okay. Now I need to figure out what's on the product side. And if you look, I've got 2 NH3 molecules, and each Na3 has 1, 2, 3 nitrogen-hydrogen bonds. So that's a total of 6 nitrogen-hydrogen bonds. So let's see, nitrogen-hydrogen is going to be right here, 391 kilojoules. So I'm going to have 6 times 391. 6 times 391 is 2,346. Okay, so now we're going to take the reactants and we're going to subtract the product. So 2249 minus 2346. 2249 minus 2346 is negative 97. So our answer is going to be negative 97. We do have to include the unit of kilojoules, okay? And then that should tell us this reaction is exothermic, okay? All right, so that was a real quick run through of the quiz. So you should be able to make corrections on that. A couple of things, and I'll put this in the weekly preview also. To do corrections, they need to be on a separate sheet of paper, and you need to explain your answers. Okay, so if something was exothermic and you put endothermic, I need you to tell me why. Okay, so for example, if I'm looking over here, this is a good example. Okay, if you put that this was endothermic, what I would want you to tell me is this is exothermic because exothermic reactions, the delta H is negative, and in endothermic reactions, the delta H is positive. So I want you to do that explanation of what's what for each thing that you missed. All right, that is that, and I will see you later. I'll see you in class. Take care.